Hi there, how are you today? I'm going to do my second part of the fractions, but first, I don't know about anyone else. We've had Blue Monday, there's Black Friday, but I think this is what the bleep Wednesday. I mean, I'm really struggling today. I don't know about you guys. I know that's not why you've tuned in. You've come to find out about fractions, but the snow is so deep up by us, and I'm looking out the window, and there's a teenager out for a walk smiling with her mum. There's two teenagers across the road building an igloo with their dad. There's some kids out frolicking in the snow, having a great time. And I'm not, slagging them at all. I'm like, in awe, actually. We are so down today in the whole house. Like, we can't get up, we can't get organised, we can't get motivated. And, I just wondered if anyone else is feeling like that today. It's just pretty, but you didn't tune in for that, so I will stop that now and we'll just do some fractions. Okay, so I'm going to turn around to my colourful page and we'll give today a go with moving on. All right, so here we go. So yesterday we talked about what is a fraction, gave examples of it, and we talked about finding a fraction of something, and we talked about how to remember the numerator and the denominator. So I'm conscious that as you go up the school, you're going to have to find out harder ones than a quarter of 12. So what I'm going to do is talk about them tomorrow. All right, because not everybody, that's more advanced, if you see what I mean. It's maybe more P7, end of P6. So we're going to talk here about adding and subtracting fractions, first of all. Now, all of these ones, you'll be able to see they all have the same denominator. And remember from yesterday, we talked about the D for denominator and down at the bottom. They all have the same. Now, we're not going to focus on the ones that have a different denominator just now, because that's more of a primary 7, sort of getting into first year type thing. So we're just going to concentrate on the ones that have the same denominator, and actually that makes it so much easier. You are going to get this reaction, I promise you, when your child is faced with this kind of sum of utter horror, because they've never seen anything like it before. They have no idea what's expected of them, and they will begin to shut down, which is a common reaction to things when children don't know how to do something. The anxiety goes up and we're just not sure, and then we're just pretty sure we can't do it. And we kind of do that as adults as well, to be honest. But adding and subtraction fractions is not only difficult to say, but it's thankfully easy to do. So all you really need to remember is that because our bottom numbers are the same, we don't need to do anything to them. We just take that over, okay? Because we're talking about thirds. Now, the way to explain this to them is you say to them that if the pizza was cut into 3 sections, it means Mum took a slice and you took a slice. So altogether, we had eaten 2 out of the possible 3 slices. And that kind of goes back to what we did yesterday, and you can go back and say, well, if we'd eaten 2 of the 3 slices, 2/3, how much would be left? 1. 1 out of 3. How do we express that? 1/3, 1/3. Okay, so moving on, we've got 2/5 add 2/5. So again, we're not needing to do anything to the denominator because it is the same. So it stays as 5, and all we do is add these. Again, this is a way to explain. You could say, notice how all of my things are to do with food and chocolate. What does that say about me? But anyway, if we had 5 Skittles and Dad took 2 and Mum took 2, how many out of the 5, would we have eaten? We would have eaten 4, and there would have been 1/5 left. Similarly here, you don't need to do anything. It's just the 9 stays the same at the bottom, and then you add across 7/9. Now, this is all you need to do for adding fractions, and this will kind of blow their mind a bit, because they'll actually think, wow, that is a lot easier than I thought. So similarly with subtracting, you don't need to do anything to these bottom numbers because they are the same. We're talking about eighths. Way to explain it could be, if we have got a pie cut into 8 slices, Uncle John comes along and he eats 7 of the slices, and Auntie May eats, and there's 2 slices. So we're just taking away 7 take away 2 is 5. That means that out of the 8 possible ones, 5 are left. All right, so across we go to this one. Again, we're keeping the 10, the bottom, and then it's just 9 take away 8. Mind blank. which is 7. Oh my goodness, no it isn't. Sorry, that's 1. Oh dear Lord. Okay, then we have, I do know what I'm doing, I promise you. Last one, we've got 15 at the bottom and then a straight 12, take away 4, which is 8. Now, these ones will lead us on quite nicely to the idea of simplifying fractions. This can sometimes get a little bit more complicated because there's usually a couple of parts to do for the sum. But what I've been saying to a lot of my children is I've been explaining that the word simplify reminds us of the word simple. And if something is simple, it is easier. And that's all we're trying to do. We are trying to make the fraction easier for us to understand. And the way then I go on to say it is someone says to you, oh, you can go and get 4/12 of the Maltesers just now. That means nothing to us. It means nothing to an adult. 4/12. How am I going to manage to split it into 4/12? That would be really difficult. So the whole reason that we simplify is to make it a little bit easier for us to understand. And what we do with these ones, the main thing that you're trying to do is you're trying to find something that you can divide the top number and the bottom number by. Another way to explain that is if you are using your multiplication grid, is saying to them, you're trying to find something that 4 and 12 both share this on the times table. So you go along, well, 4, and you go along, that's got 12 in it. You go along, 12's got 12 in it. Right, so what we're going to do is we're going to divide them both by 4. All right. Now you don't need to write these, I'm just writing it in for you. So that would be 1, and then 12 divided by 4 is 3. So it becomes 1/3. Now that's much easier for us to understand. If someone said you can have 1/3 of the Maltesers, you're splitting them into 3 equal groups rather than this. This is harder. So that's all simplifying fractions is. And I think once they get their head around it, it's actually trying to make it easier for them. It does become easier. So again, let's move on. We've got 6/36. We need to find something that we can divide them both by. Now, a common thing that a lot of people will do here, a lot of children will do, is they'll go, oh, 3. 3 goes into it. Yeah, perfect. I always say that's great. That's absolutely right. It does. Is there anything bigger that we can divide them both by? Because really, the bigger the number is the answer. If they divide by 3, they'll get an answer and then they'll have to simplify it again. So to just simplify the process, you want to find something that the biggest number that they can both be divided by. In this case, it's 6. So this one becomes a 6th. This one, you will have 5 divided by 5 is 1. 10 divided by 5 is 2. So suddenly 5/10 of a pizza is quite difficult to understand, but half the pizza, much easier to understand. And the last one, we can divide them both by 3, which gives us 1/3 again. Now, these ones now are a little bit harder. Sometimes you have a strange one like this, 15 divided by 15/25. Now, on this occasion, you can't divide 15 by 15 and 25 by 15. That doesn't work. So you're going to have to find something, a times table that they're both on. So let's go back to our grid, because it's always handy to have the grid when you're working with fractions as well. You want to find a times table that 15 and 25 are both on so that you can divide them by that number. So here we go. We're going along the 5 times table, and look, we've got 15. Oh, and we've got 25. So that means the number we're going to divide by is 5. So 15 divided by 5 is 3, and 25 divided by 5 is 5. So our answer is 3/5. This one, similarly, we can't divide the bottom by 20, so we need to think, what are both of them on? And they're both on so some people say, oh, 8. Well, that's just one of them that's got 8. They've both got to have it. So then you might say, well, it would be 4. So this one would become 5/8. 75 times 100. A common reaction to this is, well, I can't do that. Too difficult because of the size of the numbers. And you just explain to them it's exactly the same thing. What can we divide them both by? Now 5 would be fine. I'm going to just divide them here by 25, and it would be 3/4. Eventually you'll get down to the same number. And then this one, 30 divided by 60. Now this one, you could do dividing the top and the bottom by the same number and you end up with a half. So that's all that simplifying fractions involves. I am conscious of the time, but I'm going to bash on just for a couple more minutes and talk about improper or top-heavy fractions. Now, what I say to kids is, what looks wrong here? An alarm bell is ringing, something looks wrong. What looks wrong compared to the ones we've seen so far? And eventually you will get them saying, well, normally the bigger number's on the bottom and the top and the smaller number's on the top. Bingo, absolutely perfect, spot on. So there's something wrong with these fractions. That's our first clue. What I say to them is, we need to solve this. We need to solve it. They can also be known as mixed fractions. And we need to solve it because it's going to topple over. So all we're doing here is we're dividing the top number by the bottom number. So 4 into 25. Well, you're going to use your grid again, and that's absolutely fine. We've spoken about that. We're going to go along the 4 times table. Well, wait a minute, there isn't 25, but that's okay. That's okay. Well, how many times does that go in? It goes in 6 times. Okay, it goes in 6 times. It didn't go exactly though, so we've got a remainder of 1. Now, when we do our division, we did in our bus stop division, we put R1, but that's not how they do it as fractions. What we do as fractions is put your little 1 here, that's the one that's left over, and then you use the bottom number. So 4 goes into 25, 6 1/4 times. So to explain that to them in a kind of real world terms, what you're saying to them is, if you've got 4 people, let's use dogs this time. If you've got 4 dogs and 25 dog treats, how many dog treats can they each get? They can each get 6, and then there's only 1 out of the 4 left, so not enough to share for everyone to get another one. There's just 1 of the 4 left. All right, so similarly here, you've got, and they're called mixed fractions because they are a mixture of a whole number and a fraction. So improper, top-heavy, mixed fractions is what you're getting. So you're going from a top-heavy to a mixed. Here we've got 13 over 2. That alarm bell is ringing once more because it's going to topple over. So we want to know how many 2's can go into 13. Now, again, you're going to use your grid, going to go along the 2 times table. Well, the closest is 12. Absolutely spot on. Praise them. Absolutely great. You're right. 6 times. Can't go any more. But was that exact? No, it wasn't. You had 1 left over. Do you remember that we don't say it as 1 left over? We don't say remainder 1 in a fraction. We have to express it as a fraction. So we take this number at the bottom and we put it at the bottom of our answer as well. Okay, last one. Let's just go down to, this one is going to be slightly different. So this one is an improper top-heavy fraction, but it'll just go in exactly. It's not going to give you a mixed answer because it went in exactly. And the last one we're going to try is 17 over 3. So how many times? You can look at your little chart, go along the 3 times table. What's the number that's closest to 17? We can't do 18 because we don't have 18. It's 15, and that is 5 times. All right, so it goes in 5 times. But did that go exactly? No, we had our leftover 2. But remember, we can't say leftover 2. We can't say remainder 2 in a fraction. It always has a number on the bottom, and that number is the number from the beginning. All right. So I hope that made a little bit of sense. And so we've talked about our improper top-heavy fractions, changing them into mixed fractions. We've talked about simplifying fractions. And we've talked about adding and subtracting fractions today. Again, not an easy thing to say. All right, so join me tomorrow for our next little section, and I will see you later. Bye.